So the fundamental counting principle just up here says if event M can occur in M different ways and is followed by event N, so different things happening that can occur in N ways, then event M followed by event N can occur in, it would be M times N ways. I feel like that is worded really poorly, but that's the actual technical definition of it. Okay, so let me illustrate it for you here. So what I have says you're going to order a salad from a restaurant, and I got the little options here underneath. Each salad comes with a choice of a type of bread, so the breads are there too. Write all the possible choices that could be made. Okay, so by the fundamental counting principle, basically event M would be me picking one of these salads. So there's 4 of them, all right? And event N, based on that definition, would be me picking which kind of bread I want as my side. So then that would be 3 choices. So by that fundamental counting principle, it should just be 4 times 3, which would be 12 different ways that this could happen. So I'm just going to have you guys write it out so you can visually see it here. But if I pick, let me scooch it up just a little bit. Okay, so let's say if I pick the Greek salad, right? Then I could pick toast. I could pick Greek salad and a breadstick. I could pick a Greek salad and a muffin. Those would all be 3 different, totally different choices. If I did same thing, like pasta salad, I could do the toast, pasta salad with the breadstick, or pasta salad with the muffin. 3 more totally different choices. House salad, you could do the house salad with toast, house salad with breadstick, house salad with the muffin. Obviously, I'm abbreviating all these. But there's 3 more choices. And then the last type of salad, you got a fruit salad. So toast, breadstick, or muffin. And so you guys will see here, there's 12 different total choices there. That follows that fundamental counting principle. Now, to the side, and we don't have to write all these out, but it just says, how many more choices are we going to have if into this mix I say, hey, you can put chicken or steak on your salad? How many choices would I have if I added into that you could pick chicken or steak on your salad? How would that change it? It'd be 24. So then we'd have the 4 salads, the 3 breads, and then we would have the 2 choices for meat we could put on top. So then that would be 24. If you wanted to think about it from how we were just starting to write that down, like just as one example, if I picked the Greek salad and the toast, I could pick to put chicken on that. I then could pick Greek salad, toast, and steak. So just that one option would split into 2 when I add that chicken or steak to it. So every single one of these would go up by 2, so that's where you're going to get the 24. You're just multiplying it by 2. That's the fundamental counting principle. Okay, now it's not going to look like it so much, a little different scenario here, but this is also going to be fundamental counting principle. So I have 2 pictures of license plates. This first one is supposed to be Maryland's license plate from 2004, so it's a little outdated, but the other one is super outdated because it's from 1912. And just keep in mind when we do this, not as many people owned cars in 1912 as people would have owned cars in 2004, okay? How many more of the 2004 style license plates were possible than the 1912 license plates? So if you look at, let's look at this one first. So I have 3 letters, right? And then followed by 3 numbers. That's the 2004 license plate. And this is important here because we're going to do this differently right underneath in a second. It says letters or digits, so letters or numbers there could be repeated. It doesn't say I can't use them again. Okay, so if I can pick any letter in the alphabet, that'll be my first place in the license plate. Any letter in the alphabet, how many choices would we have? 26. Okay, how many would I have if the second, and it says I can repeat, like this could literally say like A, or something like that. So how many letters would I have for my second choice? Same thing, 26 again. So we have 3 different letters. They can be repeated, so we'd have 26 choices each time. Okay, the rest of the license plate is 3 numbers. How many digits would you have to choose from if you were just picking a single number to put on a license plate? It's 10, because I know that sounds weird, but you could put 0. You could put 0 and then 1 through 9. So this is actually going to be 10. Okay, And same thing. So each time it doesn't say we can't repeat the numbers. Like that could say 111 if we wanted it to. So it'd be just 10. Whenever you're ready, I'll send it to you. I'm going to record it. Okay, so 10, 10, 10. Now, what we would just do, these are basically just the different events. There's just 6 of them. So we would just multiply these all together. And this is a huge number. And this is why yeah, it is a huge number. Now, I'm just going to kind of cheat a little bit here. I'm going to do 26 to the third times 10 to the third. But you'll see it's a huge number. 17,576,000. But they need that many because you have so many people that would get license plates and they all have to be different. Okay, now for the 1912 model, obviously this is way fewer people would have owned cars at that point. So it's just 4 numerical digits, so just 4 numbers. So this would just be 10 choices for the first number, 10 for the second, 10 on down. So all of them would be 10. You could just do 10 to the 4th power if you wanted to do that. Why am I typing that on my calculator? It should be 10,000 options. Okay, I should know that. Don't judge me. All right, now here's I'm going to be a little nitpicky about this though. Okay, it says how many more 2004 style license plates would we have to choose from than the 1912? Like, how would you figure that out? How many more of you just subtract them. So just do the 17 million minus this. So my actual answer to the question, I should subtract subtract 10,000 from that. So it's going to be 17,566,000. Would be the difference. And as you add more people with more cars, you have to add more things. And then you can add different things to the license plate. Maybe we could add more numbers or more letters, whatever the case may be. Okay, now this is a little bit different, so I want you to think about this for a second. How many of each type of license plate would be possible if letters and digits can't be repeated? Okay, so I'm going to make the same 2 license plates. So this first one still has 6 spots. I'm going to start with 3 letters. All right, so let's say my first thing, I have 26 letters to pick from. Let's say my first letter was A for some reason. How many would I have to pick from for the second slot then? 25, because you did that. Okay, so let's say that was B. Now how many letters would I have for the third spot? 24. I feel like 100 people just got up at the same time. That was just so weird. Okay, so this one you just take 1 away each time. That's all it would be. Okay, now for the digits, you'd still start right at the first digit with 10 different options, but then let's say we used a 1. So then this would be 9, and then this would be 8. So each time I use a digit, I can't repeat it. So this would be a smaller number of options if you can't repeat anything. So then we would just multiply this. No shortcut to multiply that. Just got to multiply those numbers together. It's still a pretty big value. I'm getting 11,232,000. Oh, sorry, 11,232,000. Still a big number, but not as many options as if I can repeat letters and numbers. Okay, now the 1912 license plate, that's going to be very few because I just have 4 digits and I can't repeat them. Yeah.
So why is it just 26?
Okay, so for the first letter, I could pick any letter in the alphabet. Once I've done that, though, I take that letter out because I can't repeat it. So then you'd only have 25 left. Okay, then you take that letter out, and then you'd only have 24 left to pick from. If you can't repeat it, you're just going to take 1 away. That's a really good question. So same with the numbers. If I pick the number 1, I take that out. Now I only have 9 digits to pick from. I take another number out. Now I only have 8 left to pick from. Really good question. So this will actually look really similar. This would just be, if I can't repeat the numbers, because the 1912 only had numbers in it, so I'd have 10 choices for my first spot, but then I've used one of those numbers. So now I only have 9 numbers to pick from. Then at that point I've used 2, so then you'd have 8. Then I've used 3, so then I would only have 7 for that 4th slot. And then we would just multiply those guys together. This is going to end up being 5,040 if you do that. Okay. Is anybody having a question so far? Okay. Now, this, I'm going to show you a button on the calculator to do this, but what we call a factorial. It's just a little exclamation point is what it looks like. So it says for any positive integer n has to be a positive number, and it can't be like 2.5. It has to be 3 or 4, or it has to be an integer. So it says n factorial. That's what the little exclamation point stands for. And I'm going to write you the technical definition, but then we'll do an example, okay? So you would start with whatever the number is, and then you would multiply it by the number before it. So to represent that, I would write n minus 1. Then I would multiply it by the number before that, which would be n minus 2. And I'm going to write like a little dot, 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 and it would end with 3 times 2 times 1. Basically what it is, you start with the integer, whatever it is, and multiply it by every number that comes before it back down to 1. So like right underneath here, let me do one with numbers. So if I do 5 factorial, it means 5 times 4 times 3 times 2 times 1, which that's easy enough to do, honestly, on the calculator. If you just multiply these guys out, it would be 120. But there is an actual button that'll do the factorial for you. So if you guys want to grab your calculator, and if you have a scientific, it'll do it. I would just maybe have to come look at it for you. But actually, let's say we were going to do 5 factorial. You actually have to type the number that you want to do the factorial for first. So I would just type 5, and then after you type that number, hit your math button, and when you're in that screen, there across the top there's a menu that says PROB, that stands for probability, and you'll see the little exclamation point is number, it might be different on different calculators, on mine it's number 4. So you just arrow down to that, hit enter, excuse me. And if you've already typed the number before you started that out, there it'll go for you. And again, it's just 120 just to check. So see if you guys calculate here for me. You could do it by hand if you want to type all the numbers in, or you can use that little shortcut from the math menu. So see if you guys can do 8 factorial and 12 factorial. And if anybody needs help with their calculator, I will be happy to help you. I'm just going to write the answers up here real quick so you can check. The 12 factorial is a huge number. Is anybody not? Yeah.
Yeah, 52. It's actually
Can't say I watched stuff on your phone. I'm sorry, you watch a video.
yeah, it's a really good video. It's a TED Talk. What's so special? You did it. We watch it in ISB.
I think I see that.
Like, pick up all the grains of sand.
Thank you. All right. Anybody else having trouble finding the exclamation point? Okay. Now, there's 2 ways you can do this. So, a factorial can be it can be just like the fundamental counting principle. So you can kind of do what we were doing with the license plates if you want to do it. It says, in how many different ways can you arrange 6 trophies on a shelf? So if you want to think about it, how we were just doing it with the license plates, I'm going to take all 6 of these and arrange them on a shelf. So if I have 6 spots, I think I just counted that right, I'd have 6 choices for the first trophy. Then I've got that placed on the shelf. So then I would only have 5 left for the second space, then 4, then 3, then 2, then 1. But that would actually just be equivalent to doing 6 factorial. So if you arrange all of something, it doesn't say I've got 6 trophies and we're only going to put 2 of them up on the shelf or something like that. That'll be something we'll talk about on the back. But it says I have 6 trophies. How do I arrange all of them? It would be a factorial. very, very similar right underneath this. How many different ways can I organize 10 file folders on my desk? I'm going to organize all 10 of them. It doesn't say there's 10 file folders and I'm only going to pick 7 or anything like that. So this would be 10 factorial. And so, forgive, 6 factorial I think is 720, yep. So this one's 720. And then 10 factorial is a huge number. This is 3,628,800 different ways I could organize 10 file folders. I'm not going to make you guys write out all those options, obviously. Okay, is anybody having a question? Okay. Now, on the back, we're going to talk about permutations and combinations. So, really at the top, I have a little tiny example up here. Okay, it just says to the side of that, how many ways can you organize the numbers 1, 2, and 3? And the reason I have 2 separate things is to kind of illustrate what we're going to talk about next. If you guys see this, if the order does matter, which it does there, there's a ton more options than if the order doesn't matter. So you got to read the question. Sometimes they'll be a little bit more straightforward. They'll just ask you to do something, like what I'm going to have you do an evaluation here in a second of a permutation. But if you're reading through a question, you have to decide, does the order matter or does the order not matter? If the order does matter, this is a permutation. So that's the one on the left side of that table. And if the order does not matter, that's a combination. So for the same 3 numbers, you can see there are far, far fewer combinations than there are permutations for different ways I could write the numbers 1, 2, and 3. The order does matter. There I've got 6 different ways that could happen. If the order doesn't matter, that's just one way that that could happen. So permutation, this is an arrangement of items in a particular order where the order does matter. And the questions we did on the front, you could actually apply the license plate questions to this. They're very similar. So you could work with this. I'll show you in a second how the formula is. There is actually, though, a button on the calculator that will do this for you. You're not going to have to do this by hand with the factorials and everything. I just showed it to you. But there is an actual button in that same menu that'll do this. Now, it says the number of permutations of n items. Whenever you do this, the n has to be bigger, or actually I'm going to write smaller, or it can be equal. We'll talk about that in a second. But the number you have total, so like on the front when I said I had 10 file folders, the number of file folders I had would have been n. So it has to be the bigger number that you start with, and then however many out of that group you want to organize. It could be all 10, like it was on the front, or it could be a smaller number. Maybe I have 10 folders and I only want to organize 5 of them. So, but the bigger number has to go first, or the calculator will absolutely not do it for you. Now, here's an actual example with numbers. This is, I have a group of 10 things, order matters, and out of that 10, I'm going to pick 4. So let me just, they don't write it out here, let me just show you this real quick. If I actually wrote out 10 factorial, you would have like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? And that is divided by, it's the total number minus the number you want to organize. So 10 minus 4 here ends up being 6. I just want to show this to you. So the bottom of this fraction is 6 factorial. That would be like 6, 5, 4, 3, 2, 1. Everything's being multiplied on the top and the bottom, right? So I can just cross these out, any of them that match. And that would leave me, this actually has the same answer as that question we did with the Maryland license plate that only had 4 digits, that 5,040. So this is just kind of a special case of the fundamental counting principle. You can actually work it the way we did these license plate questions. It works very similarly. But if you want to use the calculator to do it, you can do that as well. Now, I just have a little example for us to practice. Now, if you have an 83, you have to type the first number first. If you have an 84, you don't have to do that. But if you have an 83, we're going to do 25 things, and out of that, we're going to pick 7 of them. So if you have an 83, type the number 25. If you have an 84, just go ahead. You're going to hit the math button and that probability menu again. So math, arrow over to the probability menu. And then permutation is a P, so that's the NPR, which should be, and it might be different for different calculators, but it should just be the second option. You go ahead, hit enter. That should take you back to the main screen. If you have an 83, you should have that 25 in front of it. It'll say P, and then you can fill in the 7. If you didn't do that, just type 25, and then just use the arrow key to get over to the other box and fill that in with a 7. And you'll see this is a humongous number. Humongous number. All right, so I'm going to go ahead and write that out. It's 242272800. Okay, so I've got, let's see. Holy cow. 2,422,728,000. So there is a ton of different permutations. If you had 25 things and you were going to pick 7 out of them, and the order mattered. Okay, so we're just going to read a question. Now these get a little tricky. So if the order matters, you're going to use a permutation. So you're going to have to read the question to decide whether or not the order would matter. So this says a teacher has 9 math books, but only room to arrange 6 on a shelf. How many possible arrangements? Okay, generally, if you see the word arrange, that's going to imply that the order matters. So if I was organizing math books, right, if I put my Algebra 2 book first and then my Geometry book second, that would be different than I put the Geometry book first and the Algebra 2 book second. So the order does matter here. Now, if I have 9 to pick from, and I only have room for 6, this order matters, so I can do the permutation. If you liked what we were doing with the license plates on the front, you can do it that way too. I have 6 spaces available, and so I would have 9 for the first, 8 for the second, 7, 6, 5, 4, and there I've got my 6 choices. So there's 2 different ways to do that. If you want to do the permutation on the calculator, or if you want to do by hand, you could do it either way. So if you have an 83, just type the 9 first. If you don't, you can just go into that probability menu, and PR is what you want to pick, and this will tell us we got 60,480 different ways that could be done. Okay, another one that tends to be something that would lead you to know it's a permutation. They'll say something about people running a race, or cars doing a race, or finishing first, second, or third, or if I assign a specific position to a specific person, or something like that, that'll tell you it's a permutation. Here it says 8 students run a race, and then it lists first, second, and third place will win medals. So here the order would matter, because maybe if you win first, you get a different medal than if you get second. So if those people switched, then the order would matter here. So in how many ways can 8 runners finish first, second, and third? So this would work like this. You could do 8, and then out of that group, we want to organize 3 of the people. Or if you liked what we were doing on the front with the license plate, this can be done with just a fundamental counting principle also. There would be 8 possible people that could finish first, but then somebody's finished the race. 7 people that could go next, and then 6 people that could go after that. So 2 different ways. They should both give you the same answer. This would be 336 different ways that could happen. The permutation, the order matters. Now the combination order does not matter. Order does not matter. So you're not going to see like we're going to do something in a specific order, or we're going to play something in a specific lineup, or things like that. You're not going to have the order matter when you work with the combination. These are far fewer than the number of permutations. We did the permutation at the top with this same example, 25. If I have a combination with 7, I just want to have you guys practice this real quick, and you'll see this is a very much smaller number. It's in that same menu, that math, and then arrow over to the probability. And then I think this one's number 3 on that list, but it might be different for different calculators. Again, if you have an 83, you have to type the 25 first and then get to that menu. Or you could use, if you want to use the formula right above there by hand, you could do that too, but it might be faster to use the menu. This one you could not do like what we were doing with the license plates, the combination, because it removes all the extra repeated patterns. So let's see. What was I doing? Math and CR for combination. So bigger number has to go first, smaller number has to go second. And you can compare to the top. The top one was like 2 billion, and this one is only 480,700. So there's far fewer combinations, because anything that would be the same values, same numbers that repeat, we would remove that because the order does not matter. And I just have 2 little examples here at the bottom. Says chemistry teacher divides the class into 9 groups. Each group submits a drawing of the molecular structure of water. If the teacher selects 4 of the 9 drawings at random to display in the classroom, in how many ways can he just select the drawings? Okay, the reason I know this is going to be a combination, they don't say anything like this group's has to go on this wall and this group's has to, it doesn't say anything specific arrangement or anything like that. We're just going to display 4 pictures so everybody can see them. So if there were 9 groups, I just want to know how many combinations of 4 we could put up on the wall so everybody could see them. No, the order does not matter there. And so, go fill this in. 9, and we're going to get 4 out of that. If you guys don't know, let me show you this real quick. If you have a combination on the screen, you're going to do another one. If you want to just hit second enter, it should bring back what you just had, but you can edit it if you want to do that, if you've already got it on the screen. I'm going to do that for the last one. Last one says, how many different teams of 11 players can be chosen from a soccer team that has 16 people on it? Doesn't say anything about this person has to play this position or anything like that. So just how many people are going to be on the field, how many 11 player groups. This would be 16, and out of that we got to put 11 people. I don't know why I just did that. Should be 4,368.